Hi friends, welcome to Edupedia Word Videos, your destination to free online education. In this video, we'll be starting a new chapter, Similar Triangles. This will be an introductory video to this chapter. We'll start with similar figures and then move on to how to realize two similar polygons, and then we will develop a brief idea, a brief concept about similar triangles. So let us start with similar figures. Friends, here three figures 1, 2 and 3 are shown. Clearly the shape of figure 1, 2 and 3 are same, but figure 1 and 2 have shape and size both same. That is, 1 and 2 both have same dimensions. But if we talk about same shape, then the figures 1 and 2 and the couple 2 and 3 and the couple 1 and 3, or the triplet 1, 2, 3, all have same shape. The figures that have same shape are known as similar figures. By same shape, we can easily determine these shapes by just viewing them by our eyes, whereas those figures that have same size as well as shape are known as congruent figures. Now we can, even by seeing some figures, easily say that they are not actually having same shape. For example, we here have ellipse, cylinder and a pentagon. All these figures don't have same shape. Therefore, they are dissimilar figures or not similar figures. Now let us have an example and a counter example of similar figures, basically the similar polygons. Friends, let us first know what a similar polygon is. Friends, polygons are closed figures that are made by certain set of lines. Now, for polygons to be having the similar shape, they must have equal corresponding angles, and they must also have corresponding sides proportional. By proportional, we mean that their ratio, the ratio of corresponding sides, must be same. And it is obvious that two polygons to be similar, they must also have same number of sides, because otherwise they can't form the same shape. So here is an example of a similar polygon. Here we can say that there are two polygons PQRS and ABCD. Let us first check the first condition, that is equal corresponding angles. Clearly angle P equals angle Q equals 120 degree. Similarly, angle P equals angle A. These two angles. Similarly, angle Q, this angle, equals angle B, that is 60 degree. Similarly, the angle R equals angle C equals 120 degree, and the angle S equals the angle D as 60 degree. So their corresponding angles are same. Now let us check their corresponding sides. PQ over AB, PQ is 4 and AB is 2, so the ratio becomes 2. Similarly, QR ratio, this QR ratio BC is 6 over 3, which is again 2. Similarly, SR ratio DC is 5 over 2.5, which is again 2. Similarly, PS ratio AD is again 7 over 3.5, which is 2. So all the ratios are same, that is they have corresponding sides proportional, and also they have the same number of sides. Hence these polygons are similar polygons. Now let us have a counter example, that is a false example, that is an example of non-similar figures. Here we have a rectangle and a square. Now friends, if we rename the rectangle as ABCD and the square as PQRS, friends, these two are also polygons. So for their similarity, for these two polygons to be similar, they must have same corresponding angles and same ratio of corresponding sides, or the corresponding sides are proportional, and same number of sides. Clearly they have same number of sides, that is 4, so this condition is true. Now we know that for a rectangle the angle, each angle is 90 degree, that is length is perpendicular to breadth, breadth perpendicular to length by this 90 degree angle. Also we know that in a square the angles are again 90 degree, so they have same corresponding angles, that is two conditions are true. But let us check the corresponding sides, the ratio of the sides. We know that in a rectangle the opposite sides are equal, that is AB equals CD equals 8 and AD equals BC equals 6. Similarly, this was for rectangle, and in the square we have PQ equals QR because all the sides of a square are equal. So PQ equals QR equals RS equals PS equals 6. That is 6 units. The units can be centimeter, meter, etc. So the corresponding ratio of sides, that is AB over PQ, is 8 over 6, which will be 4 over 3. That is something greater than 1, or we can say 1.33, and the ratio BC over QR equals 6 over 6, that is 1. Clearly from the first two sets itself, the first pair, the ratio is 1.3 and 1, which is not same. So this condition, the same corresponding sides are proportional, is false, and hence this is a counter example. That is, the figures, not non-similar figures. Now with this amount of discussion, let us have some examples or some questions to clarify our topic. Let us have a statement and check whether it is true or false. The first statement says all squares are similar. Friends, let us have some example of squares to clarify this statement. Let us have this ratio, the side of the square as 4, here 6 each, and here 8 each. No doubt they have same number of sides, so first condition is automatically true. They have same corresponding angles, always 90 degree. Therefore angles comma side, this condition is checked. Now we have to check the number of sides, the corresponding ratios of sides. So here for the first, if we can check the ratio of just one set, that is AB over PQ, this will be the same for whole the sides of this couple, because they have same dimension of the sides. So for the first set, that is A, B, C, D and P, Q, R, S. Here we have AB ratio PQ as 4:6. So it will be same for BC ratio QR equals CD ratio RS equals DA ratio SP, because always it will be 4/6. Similarly for the second couple, that is this one, PQRS and MNOT, the ratio will always be 6/8. Similarly for the first and second couple, it will always be 4:8. Hence the corresponding sides will always be in the same ratio. Hence this statement is always true. That is, all the squares are always similar. Now the second question says to check whether these two figures 1 and 2 are similar or not. Friends, they have same number of sides. Now the angle, it is difficult to determine. First let us check the ratios of corresponding sides. Friends, if this side a perpendicular is drawn from this side MN to OP, then this portion will be X, and this portion will also be X if this portion is X. So this some extra distance, this part and this part, let it be delta X and delta X. So the ratio PO over CD, let this side be Y. Since ABCD is a parallelogram, so the AB will be equal to CD, that is Y each. So the ratio PO over CD will be X over Y, but the ratio MN over AB will be X plus delta X plus delta X. Or we can say, if this delta X is not equal to this part delta X, then we can assume it as delta P, another variable, or as a whole we can use this delta X plus delta X as delta T, say. So it will be MN ratio AB as X plus delta T over Y. So all in all, these two ratios are X by Y and X plus delta T over Y. So this ratio becomes X by Y plus delta T by Y. Clearly the two ratios are not same. Here it has some addendum with X plus Y. So the ratios are not same here, hence these two figures are not similar. Now here is one more statement which we have to check if it is true or false. The statement says two congruent triangles are similar. We have to check if it is true or false. Friends, what we know about congruent triangles? The congruent triangles have every dimensional parameter same, as well as their angles. That is, this angle will be equal to this, these two angles will be same, this with this part, and this angle with this part. Moreover, their sides will also be same, that is, they have the same ratio of their sides, as well as the same value, the length of their sides. So angle A will always be equal to angle P, angle B will always be equal to angle R, and angle C will always be equal to angle Q. Similarly, AB will always be equal to PR, and AC will always be equal to PQ, and BC will always be equal to RQ for congruent triangles. So this is the condition for the first condition for similarity. They also have same number of sides, so two conditions are fulfilled. And about the ratios of corresponding sides, AB over PR will be equal to AB over AB, because from here we can put PR equal to AB, that is 1. Similarly, AC over PQ will be equal to 1, because we can put PQ as AC, and BC over RQ will always be equal to 1. So they will also have the same ratio of corresponding sides, hence they will also be similar. Therefore two congruent triangles are similar. Hence, this statement is true. Now let us move on to similarity of triangles. Friends, we have seen earlier that for polygons to be similar, they should have same number of sides, same angles, and same corresponding sides ratio. Therefore, triangles, they will always have same number of sides. So there are two conditions which must be fulfilled for two triangles to be similar. The first condition is they should have same value of corresponding angles, and the second condition is they must have proportional corresponding sides. Thus, in this figure, there are two triangles given, ABC and triangle PQR. We can see that angle A equals angle P, which is 60 degree, these two angles. Similarly, angle C equals angle R equals 70 degree, and angle B equals angle Q equals 50 degree. About their corresponding ratios, AC over PR equals 3 over 6, that is 1 by 2. BC over QR is 4 over 8, that is again 1 by 2. And AB over PQ equals 2 over 4, that is 1 by 2. Thus they have same corresponding ratios. That is, triangle ABC is similar to triangle PQR. The two similar triangles are denoted by this sign, this symbol, this curvy symbol. Now let us compare ABC with MNO. We have to check what are the corresponding vertices. Since M is centered at 60 degree and here A is centered at 60 degree, so A corresponds to M. Similarly, angle 50 is centered at O, and here angle 50 is centered at B, so B corresponds to O. Similarly, the angle C are centered at angle 70 degree are centered at C and N respectively. So we have to check the triangles ABC with triangle MON. Clearly they have the corresponding angles same because we have just checked out. Now let us check their ratios, corresponding ratios. We have derived a sequence ABC and MON. Now the corresponding sides will be AB and MO. That is, if we have to check AB, then the ratio will be taken with MO. So AB, why we have done so? Because we have just checked where are the centers of the given angles. We cannot randomly choose any side, that is CAB with NO. It's not the case. So AB over MO is 2 over 8, which will be 1 by 4. Similarly, BC over ON will be 4 over 6, which will be 2 by 3. Similarly, now these two terms will give us AC or CA over NM. Now CA is 3 and NM is 4. Clearly 1 by 4 will be 0.25 and 2 by 3 will be 0.67. These two ratios are not equal, 0.25 and 0.67, and hence triangle ABC is not similar to triangle MON. Now let us check the similarity of the triangle ABC with triangle DEF. Let us first check what the sequence of the sides will be made. The angle 70 degree is at C in triangle ABC, and in triangle DEF it is at D. Angle 50 degree is at B, and here it is at F. Angle 60 degree in the triangle ABC is at vertices A, and in the triangle DEF it is at the vertex E. So the triangle will be, if we go this way, then the sequence of the triangle is triangle ABC and triangle EFD. So clearly they have the corresponding angle same, by which we have just derived out this sequence. Now let us check the corresponding sides ratio. From these two triangles we will check AB ratio EF, the first couplet. Now AB is 2 and EF is 4, so it is 1 by 2 or 0.5. Now the second sequence formed will be BC and FD. So BC over FD is 4 over 8, which is again 1 by 2. The third sequence will be CA over DE. So CA is 3 and DE is 6, so it is again 1 by 2. So the three corresponding ratios are same, that is 1 by 2 or 0.5. Hence the triangle ABC is similar to triangle EFD. So this was a brief introductory video on similarity of triangles. Thanks friends for watching Edupedia word videos. In the upcoming videos we'll be learning basic proportionality theorem and some other theorems on triangles to find the similarity of triangles. Thanks friends.